Hey students, in this video you're going to learn about the distance formula and the midpoint formula. So on this first example right here, they're telling you to make a right triangle with the 2 points that are given in this coordinate grid. So if you notice the A and the A right here are the same coordinate grid, the coordinate point, that point is going to be -4, 3. So from the 0, you move 4 spaces to the left and 3 up. And then the point B is going to be right here, which is 3, -2. So 3 spaces to the right, 2 down. So with these coordinate points, we will practice how the distance formula makes sense. But logically reasoning behind this, we can say that we can apply the Pythagorean theorem, which is when right triangles are created. You have the A and the B side, which are the shorter legs, and then the C side, which is the longest leg, which is hypotenuse. Not the longest leg, the hypotenuse. That's what it is. The formula for Pythagorean theorem was A squared plus B squared equals C squared. And here you need to understand that we're just finding the distance between 2 points. So we're always going to be looking for C. So we're still needing to do A squared plus B squared as part of the formula. But then we need to undo this squaring part. So that's where we will do the square root on one side, and what you do to one side, you do to the other. The square root of C squared cancels, and you're left with just C, which is the distance from A to B in this case. And then on this side, we end up doing the square root of A squared plus B squared. And that doesn't change. That's what the formula actually is. Square root of A squared plus B squared. And that should give you your hypotenuse, your longest side, all the time. So these right triangles are created whenever you have 2 points. And if you look at the formula, it is technically saying A squared plus B squared. And we're doing the square root of that, and that will give us our C value, which is the distance from a point to another point. So using it in algebra, we need to look at our x values that are on each point. So in this case, the x value is -4 and 3. And we're going to be subtracting the x values from each other. We're going to do -4 minus 3, x minus x. We close the parentheses and we square it. And then we add, so that's A squared plus B squared. B squared is formed by y minus y. So look at your y values in the same order that you got your x values. So -4 minus 3. And then you're going to do 3 minus -2. 3 minus -2. And then that's going to be squared. So this is your A squared plus B squared. And this is going to equal your distance, which is your C. You do have access to the calculator, but you can always simplify step by step here. -4 minus 3, that gives you 7, -7 squared, plus 3 minus -2, a double negative creates an addition of 3 plus 2, so that gives you a 5 squared. And you can always use your calculator to double check these additions, or just type this in your calculator. To keep simplifying by hand, we're going to do 7 squared, which is 49. -7 times -7 is 49. 5 times 5 is 25. 49 plus 25, that will give you square root of 74. So we can keep going, and then that is the answer. So be comfortable with square roots that are not perfect squares. If you want to do it all in one step, you could have also just done the square root of -4 minus 3, close it, and then square it, plus 3 minus -2, close it, and then square it. And then it gives you a decimal. So that's the downfall about a calculator. You do want to have the exact answer, which is the radical form, the square root form. So if I was to type square root of 74, it confirms that it is the same decimal, but keep in mind that this is the answer you might see in the test, not the decimal version of it. So that's how we find the distance between 2 points. And again, that just means that the distance between those 2 points was about 8.6 units. On these examples below, we're just going to practice plotting these 2 points and then forming those right triangles to create a visual representation of how to find the distance between those 2 points. So for example, 2, 4, we're going to plot that 2, 1, 2, 3, 4, that's right there. And then 3, 7, we're going to do 3, 4, 5, 6, 7. So it creates this little tiny line right here. And to find the distance between the tiny line, we're going to form a right triangle. And you can go either left down or right up. It doesn't matter as long as you kind of visualize that a squared plus b squared. This is 1 unit, and this is 3 units. So if you're doing the Pythagorean theorem approach here, you're doing 1 squared plus 3 squared equals c squared. But keeping in mind that we can save ourselves the step of squaring by doing the square root of those two added. So we're going to write distance equals the square root of 1 squared plus 3 squared. So the visual representation helps you avoid the plugging in of the x's and the y's. If you want to do the x's and the y's, you can also see it as 2 minus 3 squared, and then plus 4 minus 7 squared. So the distance between this is 1, and the distance between this is 3. So that's how we find 1 and 3. Here, that simplifies to equaling square root of, let's plug it in, square root of 1 squared plus 3 squared. And that equals this decimal. So again, the decimal version of this won't be pretty. We want to simplify this as much as possible. So we're just going to square these, and it's going to be square root of 1 plus 9. 3 times 3 is 9. 1 times 1 is 1. And then your answer is square root of 10. The distance for these 2 points, it's square root of 10. But if you want to write down the estimation of what that is in distance, it is about 3.60. All right, let's try it again in the next 2 examples. We're going to have, and again, you can pause this video and do the work and then just fast forward the video to where you need to check your answer. So we're just going to keep repeating the same steps. 0 to negative 2, negative 5, 1, 2, 3, 4, 5, and then positive 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's all the way up here. And the other point is here. So the line is from here to here. To find the distance between those 2 points, we want to kind of sketch to ourselves that triangle that is created to visualize the distance from each x to x and then from which y to y. So 1, 2, 3, 4, 5. This is about 5 spaces from here to here. And then this from here to here, it's about 12 because we have 10 up and 2 down. So that's about 12. To get that accurately with the numbers, we do want to follow the formula of x minus x plus y minus y. And they're both squares. So that would be 0 minus negative 5 squared plus negative 2 minus 10 squared. And if you want to do the mental math, this is 0 minus negative 5, so it becomes a plus. So that's 5 squared. And negative 2 minus 10, that is a distance of 12 spaces. We have negative 12 if you want to write the accurate answer for that. But again, it won't matter because negative 12 times negative 12 is 144. And then 5 times 5 is 25. We're still doing the square root. This results in adding these two, which equals 169. And if you check in your calculator the square root of 169, it equals to 13. So in this case, the distance will equal 13. All right, let's do the next two problems. Again, if we want to make this a shorter, faster step, we just want to visualize the spaces between x's. So square root of x's, so negative 3 minus 4 squared, plus square root of y subtracted, so negative 2 minus negative 5 squared. And negative 3 minus 4, that's negative 7 squared. Negative 2 minus negative, so that creates an addition right there when you have a minus negative. And that results in 3 squared. So negative 7 times negative 7 is 49, and 3 times 3 is 9. So now we have 49 plus 9, which is 58. So square root of 58. You want to get an accurate number of what that looks like in terms of decimal. Square root of 58 is about 7.6. And that's how easy you can find the distance between 2 points. Just apply the formula of the difference of the x's squared plus difference of the y's squared, and then the answer that you get, you got to do the square root of that. So for example, here, one more, we're going to do the square root of 12 minus 12 squared, because it's x minus x squared. And then we're going to add the y's, so 7 minus 0 squared, because we're adding y minus y squared. So if we simplify this, 12 minus 12 is 0, 7 minus 0 is 7, and then 0 squared is 0, 7 squared is 49, so we have 49, and all of these are square roots, so square root of 49 equals 7. So the distance equals 7. So that's a preview of the notes of the distance formula.